Hi everyone. So, as Richard said, I work for Edity. We're, I'll tell you a little bit about the company in a minute. First, I just want to address the title. So, this was now supposed to be 111 steps of anything in 30 minutes. It was supposed to be a binary joke of like 7 steps, but that was like title first and content second. So, I'm not sure exactly how many steps are in this. But I just want to tell you a little bit about the company and the story. Like this talk is really about a story of a problem we had to solve in Node and how we solved it.
Sorry, can you speak closer to the mic?
Sure. Yeah. Okay. It's better. So Edity is basically started. It emerged out of a large private academic institution that had enormous success building a platform in Node to deliver online learning content. It was so successful that they had other academic institutions come to them and say, how do we get on this? So they decided to form a startup. And so the technology they had was functional and, like I said, really successful. But what they needed to be able to do, first off, was bring other customers, other users onto the platform. So just a brief overview on the technology stack. So it's Node with Seneca for managing microservices and actors, Express and MongoDB for most of the storage. All of that is running in AWS with Docker containers on EC2. So it's running perfectly in production, no problems. The challenge was how to scale this so that you can quickly support multiple customers. So that was the first challenge, and that's what this story is about. So I'll start with, if you can make it out, a look at what the system looked like originally. This is like a simplified version of it. We've got our EC2 instances, the large orange bit there, and I've got like 5 sample services running there. And then you have like elastic load balancers at the front, propagating API requests onto these containers. And then you've got your Seneca propagation, which is like microservices communication over Redis. And then every service had its own database. So it had its own database in Mongo. Apart from that, we had like buckets for file storage, and a couple of external systems like mail servers and such, like external providers. So like, there's a lot of different ways to solve the challenge of turning a single tenant system into a multi-tenant system. Like this is the quickest way to do it is you just explicitly copy and paste your entire infrastructure. So that's the quickest way to bring a second tenant on board. But obviously it doesn't scale particularly well. Your costs are linearly increasing, your maintenance becomes a nightmare, and while you might be able to get a bit of a business head start and get to market quickly, you really can't do it for any serious length of time. So like I had experience doing multi-tenant systems in Java in the past and that sort of thing. But the first thing you need to do is think about like what are the considerations you need when you're adding a new tenant onto your platform. Because like not everything is like GitHub where it's free sign-up and everything's up and running right away. There's different ways of achieving multi-tenancy, and it depends on how you grow the business as well. So you need to ask, how often are you going to provision a new tenant? So how quickly do you need to be able to react and scale basically? How big are those tenants going to be? How much load are they going to put in your system? What are the usage patterns going to be like? What is the business model? Are you going to have a free tier? Because if you have a free tier, then you've got potential for you can't really predict. If you're selling direct to the customer, kind of business to business, you can look at managing your deployments a bit more effectively. And then all the other considerations like what does it mean for how we work on a daily basis? How are we going to monitor this explosion of infrastructure? How do we maintain it? What's the deployment model? So when you ask those questions, it kind of sets the priorities for how you approach this. So this is really like the background. We knew that we'd have lots of small tenants initially. A lot of those would be just evaluating the platform. Their user numbers would be quite low. A lot of the content, so a lot of the usage is going to be just pulling static content, because a lot of the course material, the e-learning material, is is HTML. There's not a huge amount of traffic as your number of students grows, which is a good thing. And then you'll have your few larger enterprise customers with higher expectations on uptime, maintenance levels, etc. But even those will start small, they'll get their courses online, they have academic year cycles, so you don't necessarily have to go all up front, large cluster managed your SaaS. So the other thing you need to consider is it's not all about how it's going to operate in production. So if you have a multi-tenanted system, it means that impact is going to be reflected on the desktop of every developer or tester or whatever working on the platform. So if you're going to be debugging and developing in this mode, what's your development environment going to be like? If I have to run 4 tenants in order to develop some feature, how am I going to do that on my laptop? Like, do I actually have the hardware to support that? If it's going to mirror your production environment reasonably well, you have to think about that as well. And then, so how many processes am I going to run? How many containers? Do I need extra VMs? Do we have to get hardware? Where are we going to host it? All that kind of stuff. So this led us to, I think, what is the sensible approach of trying to keep the changes to your infrastructure as close as possible to your single tenanted infrastructure. So the rule there is first share all the resources. And only duplicate something or replicate something if you really, really have to. So this is your starting point. This is your golden rule for your first approach to SaaS. Once you duplicate something, you increase the overhead. Even if you automate it, you've got the effort to determine what tooling you're going to use to automate it, and ensure that's running effectively. And when you're at that stage of moving from single tenant to SaaS, it's really not something you need to contend with. So share resources wherever possible and isolate only when required. What that means is no new hardware, so no new physical or virtual machines. Try to avoid adding any containers or any other processes. And that allows you to start quickly. Your development environment is almost the same as what you had at the start, and you end up with lower maintenance, and obviously your costs are pretty much the same as what you had to begin with. And that's really suits just fine, because the load initially anyway, you're actually just going to you're just getting more value out of your initial infrastructure. So this is the original viewpoint. We wanted our multi-tenanted system to look as close to this as possible. Except for one thing, so we did need to add one new service, which is the Tenant Registry. And this is where you store all of your customers, and it's essentially a small CRUD system where you've got your tenant name, the domain names they're going to access the system at, maybe a logo, and a few other configuration details. So I said share where possible and isolate only where required. And where you do have to isolate is when you store your data. So, I mean, this is I suppose obvious anyway, but there's a couple of different ways to store your data. So there's 3 standard approaches to doing this. You can use a document or a row per tenant, which is fine. You just add a column or a field to your table or collection. Index that column, and away you go. You can add a new collection or a table for every tenant, which might be okay for some databases, but like we're using Mongo, and collections don't scale well, so you're advised against doing that, or just use a database per tenant, and wherever possible. I think that's the best approach to take. Certainly, like, if you want to do anything serious, and if you're storing any kind of serious customer data, just from a compliance and data protection point of view, it's just better if you can have them in separate databases anyway. That way you could have them in separate continents, separate availability zones, different infrastructure providers for your database backend, and you don't have to worry about anything like that. So, like, just to give a bit of context of what our system actually looks like, and for those of you who haven't seen a lot of the stuff or used Seneca, this is what one of our services would look like. It's a simplified version. This is a student registration service. So at the top there, we're just defining an action that will take a record from a request to handle an action, and we save it in the database. And then in the Seneca.add, what you're doing is defining a pattern that will invoke that action. So any other service of the system will be able to invoke it using this pattern. At the very bottom, we're putting a HTTP API endpoint in front of that, so you've got a post endpoint. So this is the kind of glue that our system is built with, and everything we have to do in order to make multi-tenancy happen relates to this kind of coding. So if we wanted to store, obviously the goal here is like we're going to have to change our code, right, to handle this. Everything was single customer, was single platform, internal platform essentially. So how do you move that to a multi-tenant system? So what we wanted to do is basically understand how this kind of action, like if you see it start the save command, that's part of the Seneca store feature, which is like an active record type model for storing entities. So how do we make that tenant aware? So we had a look on the Seneca docs, and on this particular tutorial, there was this line talking about the entity namespace. So entities in Seneca is your record definition, a pointer to your record. Which record am I talking about? And that's made up of 3 parts: a name, a base, and a zone. And normally you'd use a name at least. We were using a base and a name, because base allows you to just kind of namespace your entities a bit. But zone we weren't using, and it said here the name for a data set belonging to a business entity or customer, for example, tenant 1. So he thought, brilliant, like this is inherently designed to support multi-tenancy. So let's see how it works. So we just put together this little test prototype piece of code which defines 2 Mongo store plugins for Seneca. So you can see the Seneca use here. That's saying that everything that comes into your system to be stored that has its own test goes into the database called test2. And the name is defined there, and it's on your local database. And then we inserted a record for each one, and it worked. Right? We were able to go into the Mongo shell and see that data had been isolated by using zones. So that was like step 1. So obviously what we're doing here is essentially, because we're using our existing hardware, we're doing tenant routing based on some sort of tenant context. Seneca already has all of that glue for binding all your actions together and routing them around your system, and it has some support for aggregating or partitioning your data. So what we could have done was change all of our store operations to use, to specify the zone manually, and that zone could come from an argument to our action. But this would involve changing thousands of functions in our system. So we were looking for some way to do this a little bit more cleanly and avoid changing code where possible, because we didn't want to introduce any stability problems in a production system. So what we were looking for was some kind of in-band context. So as your messages are passing around the system, right, it's an actor model system. So you have messages firing all around you. You have a chain of actions firing through multiple actors. At any point in that system, how do I know what tenant this action relates to? So which domain initiated this request? So this was a bit of a head-scratcher, and kind of like sent this tweet in desperation like to Seneca.js saying, is there any way to send inbound data through multiple action codes, right? It's generally not advisable to ask a question like this on Twitter, but like I said, it was desperation, and the polite people at Seneca kind of got back and said in a more polite way than I would have, would you mind creating a GitHub issue instead of a tweet? So we created the GitHub issue, and like within hours, I think somebody got back and said Seneca has correlation IDs that embed both a message ID and a transaction ID might be what you need. So we looked into the code and saw that this was true. Seneca already has the concept of an identifier which is passed all the way through your system, so that at any point you can trace the flow of a request through your system. So this was like a eureka moment. So we looked into it further and said, okay, all we need to do is take that and be able to push, like instead of just a transaction ID, we just want to marshal our tenant context and stick it into that. So that's why we wrote this Seneca context. So we open sourced this, and this is like a couple of Seneca plugins that allow you to just handle creating context at any point in your system, pushing it into Seneca, and then having Seneca propagate that throughout your system. So it avoids all this explicit passing through arguments in your actors. What you end up with something like this. So your request begins with somebody in a browser making a HTTP request, and that's at a subdomain like d.edp.com. Seneca Web, which is like essentially Express middleware, captures that. We add a Seneca Web plugin. That Seneca Web plugin is essentially another Express middleware. And in that web plugin, we're able to look at the host, talk to our tenant registry, and say, which tenant is this? We determine the tenant, and then we stuff that into the context. So once it's stuffed into the context, we can propagate that action through multiple levels in our system, across transport boundaries, across the internet, and the context remains. So it was kind of taking shape at this point. Like this was avoiding creating a lot of extra boilerplate coding every actor we had. And we had hundreds of actors. Just like, in case anyone's curious on the whole DNS side, and how we approach this, we switched to using Route 53 for this, because you can programmatically provision subdomains if you like, but obviously you have DNS propagation issues there, so what we do is just provision wildcard subdomain. That wildcard subdomain can be just an alias for your load balancer. And then you can also do that for your staging environment and your local environment. So you can put in like a DNS entry instead of just putting in your host's file. You can put in a public DNS entry, which will mean every developer will be able to run multi-tenanted access in the same way. Once you have that, as you scale, if you do start adding other containers or instances as you want to scale horizontally, then you can start programmatically registering customer-specific DNS. So then, the other difficult problem we have here, we've got these hundreds of actors. Each of them may have many store operations. So even if we do have the tenant context at any point, how do you avoid setting that zone for every operation? So this required a little bit of digging into the magic that is the Seneca codebase. And I think we came up with another Seneca plugin, which I think is pretty neat. And doing it this way kind of challenges you to think, would this be possible if you weren't using Node? I'll show an example later, but I've had experience doing this kind of thing with Java and OpenJPA sharding and stuff, but I don't think it could be done like this in any other development or in any other language for that matter. So this plugin uses something called Seneca Wrap, which is a Seneca API, which is like adding an interceptor. So it's saying, I want to intercept all actions that are related to entity. So anytime somebody's trying to read or query or say something, I want to know about it, I want to intercept it. When I do that, I'm going to look up the context from Seneca. I can provision the database on demand, configure the store plugin for Seneca, so I'm saying here's a new store for this tenant. You set the zone into the action, and then you call Seneca.prior, which is like chaining your interceptor back to the original function that would have been called. So once we've done that, that was adding two plugins, essentially. All of the other code in the system remained exactly the same. We just changed how we configure our system. And then the result of it was that the system then looked like this. So it looks very similar to the previous infrastructure. The only difference is that we've got multiple databases, sets of databases for each tenant. And again, like those are provisioned on demand, so if the tenant isn't storing any data there, it's costing you nothing. We provision a separate set of S3 buckets as well. And the only additional container is your tenant one. We did actually add in the elk stack stuff here as well. Because if you've got lots of containers, having consolidated logging is useful. If you've got lots of tenants, that's useful too. So, yeah, I'd just like to show a quick code example. And I think, even having done this in our system, I was surprised at how quickly this could be done in a single piece of code. So I'm just going to bring it up here. Okay, 1 second, you can see it, but I can't. Okay, so let's increase it a bit. Okay, so you can see on the right pane I've dropped my databases, right, so there's no smoke and mirrors here. So this is our demo multi-tenanted platform. It's just over 50 lines because I added comments. So there's like 5 steps to this, so I'm going to show it there. So this is where we add a plugin to set the context, and that's all we do. These 4 lines of code will ensure that every time you have a HTTP request, the domain will be mapped to a tenant, and that tenant will then be available in all your actions. Okay? Then this is our microservice. It's one action, so it allows you to save a blog post. So we just take one argument, post content, and we're going to save that. And you can see, like, this is the entity namespace I'm using. I'm just saying this is a blog post. I'm not saying who it's for or where it came from. This part is just telling Seneca Web to put an API in front of that. And these couple of lines of code, this is our tenant registry. So this is like our tenant registration subsystem here in 3 lines. So what we're doing here is provisioning 4 tenants, A, B, C, and D. And we're saying for all those tenants, configure the Mongo Store plugin. In our real system, this is done by a separate plugin, which is kind of invoked on command, but I'm just creating it up front here to be explicit. So we're just saying for A, B, C, and D, create a new plugin, Mongo Store $A, and the map for that is to map the tenant zone to this database. And the database is going to be the same as the tenant name, which is going to be A, B, C, and D. The next part of magic is a little bit longer, so this is our interceptor. So what this is saying is wrap. This is the wrap part. So every time you say something, list something, store something, intercept it. So you take that, if the zone isn't already in it, because you can always explicitly define the zone, then what we do is, so this is just, there's a little bit of dark magic probably in this, in that it's replicating a lot of what the Seneca stuff is doing internally, but I don't think there's any internal APIs used here. It's pretty public. What we're doing is just creating a new copy of the message that we're intercepting, and we're putting the tenant into it as the zone. That's all we're doing. And when we're finished, we're acting, which is basically saying, send this message back to me again. And when that message comes back to me again, it'll have the zone in it. It'll skip this section, and then it'll call prior. And that prior is like the store, save, or read operation that has a zone in it, and it'll make sure that our data is propagated to the right database. The last part is just setting up your application server. So this is running Express and hooking the Seneca web plugin into Express. So that's it. A complete multi-tenanted functional system. So let's run that there. Okay. So I'm just going to execute a couple of requests here. So I added in that API endpoint. So Seneca is listening. I've also in place of DNS config, I've configured the tenant domains to be localhost. So now I'm going to make a request on tenant domain A, IA, and I'm going to write another one for B, IB, okay? And we get back the message and the ID of what we sent. So now, if we look in our database, we've got two databases configured. Right? These are on my local system. We've got just two Mongo databases. These could be in different countries. So we've already had blog post collection created for us. And there's our IA. Guess what happens next? So we've got two databases, and just through like 50 lines of code, we've been able to ensure that just by specifying a different domain, our data is completely isolated and routed throughout our whole system. Like with one microservice, this is useful, and it's a neat demo, but when you've got hundreds, it saves you a huge amount of work. So, let me just switch back here. So yeah, I mean that is essentially the end of the transformation we went through to turn to a multi-tenanted system. I just wanted to point out a few other stories that are kind of loosely related. So just on like hurdles, we didn't come across many. Like at the same time, we decided to upgrade from Seneca 0520 to 0720 or something. I can't remember. And from Node 010 to Node 4. So we were doing it all at the same time. So we did have a few more hurdles, but on this part, the thing you can't do is you can't initialize anything that might be tenant specific in a plugin before you know what tenant you're talking about. Everything has to be more dynamic. So there were some of the plugins, our own plugins and third-party plugins that did this, so we had to modify those. There's not a lot of modification, but it's something you have to be aware of. And we also put in DB initialization into the interceptors. So if you've got seed data that you need to populate, like default users or default data, that's also done the first time you need to access your database, including migration. So if you've got any automated data migration, that happens also when your collection is first accessed. And then, like, how do you provision a tenant? All you have to do, register a new record in your tenant database, create whatever external resources. So in our case, that was your bucket, S3 buckets. So that's fairly straightforward to do. You're just configuring your bucket, and managing your credentials is actually probably the most tricky part of it. And then configuring your database. We use Compose to host Mongo databases, so it's like cloud available Mongo. So in order to do that, we actually had to use Compose APIs to initialize the database when the tenant is created as well. But the end result is that the tenant provisioning is zero cost, or close to zero. And it's only when the tenant uses the system, and the more they use it, that they actually start creating value anyway, and then it starts costing you something. But because it's using your same infrastructure and the throughput is so low really, it's an incredibly cheap way of doing it. Integration testing is another useful thing, because the more moving parts you add into a system like this, integration testing is useful. So we do have a nice way of building out like integration tests that can run across the whole system. So we've also got like every service when it's brought up in integration test mode, so you can bring up an integration test environment in Docker Compose. You've got Seneca test patterns there as well, so you can start creating your setup data and your teardown data through remote calls. And then we have this like dependency graph of data dependencies. So if one service needs other services to create like a graph of data in order for it to be able to run its tests, it automates all of that for you. And the nice thing about that then is you're bringing up Docker Compose with just the instances of the containers you need for the test. You don't have to bring up multiple VMs or anything like that. Yeah, so oversight, this is like what I mentioned already. As the more variables you add into your system, the more oversight you need. So we don't have anything, we have like obviously CloudWatch metrics for certain parts of the system. We're not using New Relic or anything like that. but adding an Elk stack with Logstash, Elasticsearch, it still amuses me to use kind of like a JRuby system to manage the highest load throughput in the system, but it is very useful when you have a problem to be able to go in and select by tenant and see what is happening specific to that user. And then obviously the next part of the story is evolving. It's just like, okay, this is great for getting up and running, and it obviously allows you to have a large number of small tenants on board. Or how do you actually scale to realistic growth like this? So adding it up to a point like you can manually add instances. So you can always say create a separate environment, and these tenants are going to be on these load balancers. You just do your DNS config, and then you start automating it and putting in a clustering service like Mesos and Kubernetes and all that good stuff. But yeah, the obviously clear issue here is that there's only so many database connections you want to configure on each container. So that's something you got to be aware of, and that's when you really have to start horizontally scaling. Okay, so this is the end of it. Thanks very much. We okay? Am I okay to say I can answer questions? Yeah. Okay. Does anybody have any questions?
Well, it was a very interesting talk generally. I've been always interested in multi-tenancy and how it's done. You mentioned at the very end there about the connection issue. And I was wondering how did you architecture? I mean, obviously you have kind of one centralized kind of API, and hitting the API, and basically based on whichever the URL or the domain, you're kind of diverting to whichever different part of the service, whatever data you want to do. And I was wondering from the point of view that if you've got 100 clients or 200 clients, if you're going database by database, you're going to have, you could have, in theory, have 10 or 20, 100, 200 data connections up and running on that API.
Yeah, you just have to, I'd say at that point, you don't want to allow that to happen.
Yeah.
So you can't just launch this with free tier and have a public sign up.
Yeah.
You have to be able to manage it, and we're able to manage it.
Yes, yeah.
And we're able to be aware and predictive tenant sign up.
Yes.
So if you do have a free tier, then you have to put some sort of scaling or limitations in place.
Yeah.
By default, we'll get, like with your Mongo connection, I think you'll get a pool of 5 connections.
Yes.
You probably don't even need that.
Yes.
So you can configure it to optimize that a little bit.
Yes.
You can also configure it to start closing those connections when they're not being used.
Yes.
But obviously you have your limits there, and you have to just manage capacity.
Yes, yeah. I suppose you can always put a load balance and have the API as well, you can have a multiple instances as well.
Yeah, but you do want to optimize so that you route tenants to the domains where their connections are already open and they're already configured, rather than having all your tenants active on all your systems.
Yes.
Yeah.
So you're using nearForm.
Yes.
How's that go?
Brilliant. Yeah. So there were no issues because we upgraded Seneca. I think we had to upgrade Node anyway, so we decided to make the move to Node 4. There were no issues with Node 4. There were no breaking issues with Node 4. It just allowed us to start using ES6. I mean that's it, and when you're writing a lot of this kind of the service, the actor boilerplate, then ES6 just with the arrow functions, it lends itself more to that kind of functional model. So yeah, that part was quite sweet.
Well, at some point in the future, would you see yourself having kind of like say that the user authentication kind of service? Imagine you're going to have a user authentication service, kind of a hybrid model where you're going to have like certain data will be in a separate database for the client, and certain database will be kind of in
absolutely.
service.
Yeah. So if you can imagine, if you're building GitHub and you've got users who can have participated in multiple organizations,
yes,
they're essentially, exactly what you said. You've got a user who belongs to multiple tenants.
Yes, yeah.
And in that case, that's exactly how you do it. So you don't have to zone off your user data. You just have to tie them to a tenant record. Yeah, definitely. All right. Thanks very much. Thank you.